First question is with a potential significant loss of science data due to the loss of the Viper rover and the fact that commercial payload missions are not entirely reliable at this time, what are NASA's plans to conduct reliable precursor science at the lunar South Pole before the Artemis crewed missions begin? And so I'll start with that, and then I might throw Jake under the bus at the end to provide a little bit of context from ESDMD. But I would like to say, to start off saying that it's not just the US that's returning to the moon. It really is a global endeavor right now. And there have been a number of international partners, in addition to our own domestic commercial entities, that have attempted to land on the moon. And over the last 5 years, we've had a number of failed attempts. But I would also argue that with each one of those attempts, we're learning more and more. And actually, of late, we've had a couple successful international landings. We have had a partial success from CLIPS delivery, and we are really participating in a number of international missions as well as the CLIPS delivery, as I mentioned earlier. We had from the start of this year through the end of 2025, we have 8 planned CLIPS deliveries to the lunar surface, and we plan on selecting 2 more by the end of this calendar year in order to make deliveries kind of in the 2027 timeframe. And so it really comes down to how we are looking at the science available, the platforms available, and what scientific instruments and observations can be made from each one of these platforms. As I mentioned, we are gaining valuable lessons learned with each new attempt, and those are porting forward into all future attempts as well. We are also we have a number of instruments and sensors that are going on to the Starship uncrewed demo that needs to go before the crewed mission of Artemis 3. And so we'll also learn something from a science perspective there. And also just a note that coming back to the science loss for Viper, none of these assets or investments that we're making are intended to completely replicate the Viper data set, but we are conducting a number of other instruments and observations to actually complement the data set we were expecting from Viper. And that goes from technology demonstrations that we're expecting from Prime 1 with a combination mass spec and drill to some partnerships with ESA. We're delivering via CLIPS their prospect mass spec oven and mass spec in order to get access to the subsurface and understand what volatiles look like. And there are a number of other instruments we've selected through LSIP and PLP that will again be delivered via CLIPS or via our international partners in order to address the LPS-3 Moon to Mars objectives around volatiles. So it really comes down to the number of opportunities that exist for getting to the surface and getting that, and those early science data sets are, like I said, they're numerous. We really are focused on that effort. But I would like to turn to Jake and ask, are there, from an ESDMD perspective, any scientific data sets that would be required or useful for the early missions of Artemis in order to conduct safe early missions from Artemis 3 and 4?
Yeah, thanks, Brad. Yeah, the presentations you just saw, starting with Noah's presentation, both mine and Settle's, and then through Deborah's presentation, really trying to drive home this point about objectives-driven architecture development. And it's a wide range of objectives that NASA as a whole is charged with accomplishing. And so when you look at some of the other objectives about landing and establishing our presence on the surface of the moon, those are the objectives that our directorate is charged with carrying right now. And so when we talk about precursor data, I think the question would come up, as Brad just asked, are there necessary data products that need to happen, therefore need budget to be spent prior to the crewed landings to demonstrate that we can get the job done and get that foothold. And I've talked about this several times. The objective we have really is to try to get that initial foothold on the moon so that we can continue to develop the capabilities and do more science going forward. You know, the things that Deborah was talking about, really getting those capabilities enhanced and growing the opportunity. So, you know, all data are useful to us, and we're happy to use any data that we can get back. But at the moment, you know, our charge is to get those first crewed landings onto the surface. And, you know, we don't need more data in order to go accomplish that objective. The ISRU objectives for demonstration of ISRU down the road, farther down in our segments, probably need some of that data. But we have to get these initial crewed landings onto the surface first so that there is an Artemis program later, there's an Artemis effort later to continue to support those activities. So that's kind of a long way of saying, you know, we would love any precursor data we can get, and all the things Brad talked about. If we can get any of that data, that's great, and we'll use it. But we don't need it in order to conduct the crewed landings that we're charged with doing right now.
Great, thanks, Jake. The next couple of slides, or next couple of questions are I'm going to direct toward Settle. And they say, what details can be provided on the Italian Space Agency's multipurpose habitat? For example, is the vehicle a rover or mobile hab? And are things like crew numbers defined yet? And can you comment on when phase 2 of the MCR is planned for? Is it still planned for September?
Okay, so specific capabilities for that initial surface habitat are still under development with our partners. So some things are still being traded. It will have limited mobility as far as that's our desired capability, but not the roving capability, you know, in the tens of kilometer range as maybe once envisioned or thought of. Crew size is still under trade, but the minimum is established right now that we need to have 2 crew to be able to conduct EVAs out of that initial surface habitation. And then coming back to the MCR, currently the phase 2 closeout is still planned for September timeframe, and we look to be on track with our partners to complete that. So exciting times as that project continues to move forward and give us that capability on the lunar surface.
Great, thanks, Settle. The next one is, please describe how the STMD shortfalls, especially their ranking, can best support lunar surface HAB science. So for those of you who are unaware, STMD recently underwent an analysis of where their gaps or shortfalls exist from a technology development perspective, and ranked them. They've done that analysis and have talked about that. But STMD is currently undergoing a reorg, and they are still looking to turn those shortfalls into a proper strategy and then match that to budget. I would encourage this question to be asked again this afternoon in the upcoming session, where there will be some STMD representation, and get some direct from STMD comments at that time. Let's see. Noah, you mentioned views of the Earth will be distinctly different at the South Pole as compared to Apollo landing sites. Can you elaborate how the view will be different? And I'll add a little caveat here. Do you see any things that will be easier to perform? Any surface ops or observations will be easier to perform at the South Pole compared to equatorial destinations?
Okay, so I put a link in the chat to some of the visualizations that sort of highlight where the Earth is. Again, the distinction is that the Earth will disappear periodically, go below the horizon for some of the locations in the south circumpolar region, some of the areas that Artemis will be exploring. This means that we'll have to develop new technologies to ensure communication and rely on other opportunities to stay in contact, get the data down from our assets on the surface. It also means that you're going to have a low angle, grazing angle, right? The Earth will be right at the horizon. And I think there has to be some thought on exactly what the implications are for that for comm assets at the surface. I am far be it not a comm engineer, but the idea that you have, you know, the Earth and lunar surface in the field of view of an antenna, to me is a compelling question to understand exactly what the implications are for data downlink, for instance. It also means that periodically the Earth will be out of line of sight, and I know that there's a lot of interest in getting to areas that are Earth um, shadowed. You don't see the Earth for deep space studies, and so potentially there's an opportunity to have the best of both worlds: opportunity to communicate with the Earth, an opportunity where the Earth goes away for a little while. It doesn't go away; it disappears from view. Um, and so maybe there's some opportunities to take advantage of that unique environment. Things that are easier to do, well, certainly easier to find areas of the South Pole that are permanently shadowed, larger permanently shadowed areas. We all know that Apollo 16, 17 collected samples that were shadowed or shaded. But now at the South Pole, we have this incredible environment that has not only areas that don't see the Earth, but also don't see the sun. And so you have, again, sort of micro environments at the South Pole that we just don't have a working understanding of because we've never been there. And so that's why we're going. Don't know that that answers your question, but I know that we're also a minute and 15 seconds over time.
Great. Thanks, Noah. One other, I will take a little bit of extra time and ask this question of Setal and Jake, perhaps, but it is, how feasible is an EVA into a shadowed part of a crater that is still well illuminated by secondary illumination? And
Yeah,
I just,
I
yeah,
can start on that one, and then Settle, if you have anything to add, please jump in. But we do carry requirements to operate in shadow. One thing I want to be clear, and maybe Noah can correct me if any of this is wrong, but permanent shadow and shadow are not necessarily a completely different environment. You either can see the sun or you can't. Now, if you go extended periods of time and deep into PSRs, you may experience colder temperatures than you would on the margins of a PSR or something that's not a PSR, maybe like a quasi shadowed area, largely shadowed area. So for the physical environmental conditions that we expect to experience, we do have requirements to operate inside those. So I don't think in any way we would consider it unfeasible. It is in fact an objective. So we do expect to do that. Now, we will learn how to do that as we get these first few missions onto the surface. So again, I talked earlier about the importance of getting these first few missions under our belt so that we can better answer those questions, so that we can decide, are we staying close to the edge of that permanent shadow, or how far can we get? There are a lot of operational questions, a whole set of objectives that are operations focused that we need to learn. Just like we have to go learn science that we want to accomplish, we need to learn these things as well about our systems, how they operate, and how we can use them best to our advantage. So I think it's absolutely achievable, and we expect to do it. I don't know, Sato, if you want to add anything to that.
No, 100% agree, and kind of tacking on as we learn more about those systems, right? What are those capabilities? What is our operational tolerance and autonomy that we allow the crew to explore that, as well as what is our safety criteria to allow some of those systems to approach their lower limits, with the other factors. So, but definitely feasible, but a lot of things that have to be considered and learned before we delve into that territory. So definitely agree with you, Jake.